Okay, study guide, FRQ. What are we told? At the top of the page, the stem of our question, f is this piecewise defined function, 2x minus x squared if x is less than or equal to 1, x squared plus kx plus p if x is greater than 1. Part A. For what values of k and p will f be continuous and differentiable at x equals 1? Okay, this is just like the problems we've done in class and on the homework. All right, we got to take a look at the continuity part, which I'll just label with the C. In order for the function to be continuous, the top piece and the bottom piece have to be equal when x is 1. So let's make the top piece equal to the bottom piece. And we know that this has to happen at x equals 1, right? Because 1 is the condition where we change. Okay, so we're going to make x equal to 1, which means we have 2 minus 1 equals 1 plus k plus p. So 1 is equal to 1 plus k plus p, and that means 0 is equal to k plus p. So that means that k and p are opposite values, we just don't know what those numbers are. Are they 1 and negative 1, 2 and negative 2, 3 and negative 3, a million and negative a million? We have to find another clue. That's where the differentiability comes into play. All right, so we're going to have a differentiability part. But that means we need the derivative of f. So let's write that up here. What's the derivative of 2x minus x squared? Yeah, it's 2 minus 2x. What's the derivative of x squared plus kx plus p? It's 2x plus k. The conditions remain the same. X less than or equal to 1, x greater than 1. Now we just do the same thing that we did over here. 2 minus 2x equals 2x plus k. We're interested at x equals 1 again. So we plug in 1, 2 minus 2 equals 2 plus k. 0 is equal to 2 plus k. K is equal to negative 2. K plus p is equal to 0. So if k equals negative 2, p equals 2. Part B, find the value of f prime of negative 5. Okay, well let's go back up here. Where does negative 5 fall? Is it less than or equal to 1? Or is it greater than 1? Obviously it's less than or equal to 1. So if we want f prime of negative 5, we're going to use the derivative of 2x squared, I'm sorry, 2x minus x squared, which is 2 minus 2x. But we're not going to plug x, or rather not going to leave x alone. We're plugging in negative 5. So 2 minus 2 times negative 5. Our answer is 12. Part C. Let g and h be differentiable functions such that g is 4 times h times f. And then we see values of h and h prime, and we need to find g prime at negative 1. Well, if this is g and we need g prime, that means we need to use the product rule. So we have 4hx. We're going to derive that. 4 is a coefficient, so it stays. H derives to h prime of x. Derive the first, keep the second. Plus, now keep the first and derive f. F derives to f prime. This is g prime of x. We want g prime of negative 1. So we're going to replace all x's with negative 1s. Here we go. 4, h prime of negative 1, we see right here, is negative 3. F of negative 1, now f's way up here. All right, we need f of negative 1. Negative 1 is less than 1, so we're going to plug negative 1 in here. So that's 2 times negative 1 minus negative 1 squared So that's negative 2 minus 1, which is negative 3. F of negative 1 is negative 3. Plus, keep the 4. Now we want h of negative 1, which is 2, times f prime of negative 1. Okay, we need f prime of negative 1. Back up here. Here's f prime of x. Negative 1 is less than or equal to 1, so we're going to use the top piece. So f prime of negative 1 will be 2 minus 2 times negative 1, which is 2 plus 2, or 4. So there's our answer. 4 times 9. Negative 3 times negative 3 is 9. 2 times 4 is 8. So 4 times 9 plus 4 times 8. So that is 36 plus 32, or 68. And then last but not least, find the average rate of change of f over the closed interval from negative 3 to 1. All right. Average rate of change formula, f of 1 minus f of negative 3 over 1 minus negative 3. F of 1, head back up here, x is less than or equal to 1 means we use the top piece, so it's going to be 2 minus 1. F of 1 is 2 minus 1, so f of 1 is 1. Now we need f of negative 3. F of negative 3. Negative 3 is less than 1, so it's going to be 2 times negative 3 minus negative 3 squared, which is negative 6 minus 9, or negative 15. F of negative 3 is negative 15. So what do we have? We have 1 plus 15 over 1 plus 3, 16 over 4. So the average rate of change over the closed interval from negative 3 to 1 is 4.